So this is the value of atmospheric pressure, which is equals to 100,000 Newton per meter square, or 10 to the power 5 pascals. That is the amount or the value of the pressure which is going to be exerted by the gas or by the atmosphere in normal condition, where we are not going to increase the temperature, not going to increase or decrease the pressure, right? And if you consider the example of uh, if we consider a common example, let's suppose if we have a juice or a box of a juice over there with a straw, and when we are going to pump out whole air from that box of the juice, let's suppose now there is no liquid in that juice box and it is empty now, right? And when we are going to suck all the air from that box or that box of juice, so you observe that the box of the juice is now going to be squeezed, right? Because whole air is now pumped out. Let's suppose if we consider the example of that box and we have a straw over here, and now we only have air inside the box, right? No liquid over there. Liquid is empty from the box and only air molecules are there, right? And when we try to suck all the air from the juice box, right? So air is now going to pump out from the box. So what will happen with what will happen with that box of juice? It will,
It will be squeezed.
yes, it will be squeezed in irregular shape or in random manner. So that will happen because of atmospheric pressure, right? Because initially we have number of molecules inside the box, right? So that maintains the shape of the container, right? Or the box, because they are continuously colliding, they are creating the pressure on the box. So the shape of the box is stable. But when we pump out the air molecules from the box, so atmospheric pressure will apply from the outer side. Initially, it is also applying from the outer side, but they are in balance state, right? But when we pump out the gas or the air from this box, so now atmospheric pressure will be greater than the internal pressure. So atmospheric pressure will be greater than the internal pressure, right? So that's why this box is going to be squeezed. So this is the property of atmospheric pressure with reference to the gases, right? And now further, if we talk about the laws which is related to and which are related to the gases, so those laws will be like, if we talk about the first law, so first law is equals to, or the first law which we state is known as the Boyles law. Okay. So do you remember the basic statement of Boyle's law?
No.
Okay. So if we talk about Boyle's law, so Boyle's law basically gives you the relation between the pressure and the volume of the gas. So Boyle's law states that at constant temperature, at constant temperature, The pressure is inversely proportional so at constant temperature the pressure is inversely proportional to the volume, right? So this is the statement for Boyle's law that if we kept the temperature constant, so pressure is inversely proportional to the volume. It means P is inversely proportional to the volume. So P is inversely proportional to volume. Or secondly, if we replace this directly inversely proportional sign with a constant, so it will be equal to P is equals to constant 1 over V, right? So this is the equation for Boyle's law. Or we can also write it as if we shift this V on left hand side. So PV is equals to constant, right? Okay, so this is the equation for Boyle's law, right? And further, if we talk about the other equation, okay, so if we talk about the next situation, then let's suppose if we have multiple pressure and multiple volume, right? Let's suppose if we have initial pressure P1 and volume V1 plus we have final pressure P2 and volume V2. So P1 V1 is equals to constant, right? And it will also equal to P2 V2 equals to constant. So on right hand side we have constant, so we easily compare these equations. So P1 V1 will be equal to P2 V2, right? Okay.
Yes.
So if we have multiple pressure or initial or final pressure and volume, so we can use this equation to find out the value of any unknown value. Let's suppose if we consider a question just to practice this equation. Question is very much easy. It is not very difficult. Okay. So question is like that. A certain quantity of gas has a volume of 40 centimeter cube. 40 centimeter cube at a pressure of 1 into 10 to the power 5 pascals. Uh, find its volume when the pressure is 2 into 10 to the power 5 pascals. Assume the temperature remains constant. Okay. So this is the question. Okay, so this is the question. So we have multiple values over here. We have value of volume over here and two values of pressure over here. And we have to find out the volume. So when its pressure is equals to 2 into 10 to the power 5, right? if we need to find the values from the question, so what is the initial volume?
40.
Yes, 40 centimeter cube is the initial volume. And what will be the initial pressure? P1 is equals to 1 into 10 to the power 5 pascals. And second, we have and secondly, we have to find out the value of volume 2, right? So it means we have to use the same equation. P1 V1 is equals to P2 V2, right? Okay. Any
Yes.
So you just need to calculate the value of V2. So V2 will be equal to P1 V1 over P2. So we can easily find out the value of V2. I'm just writing the final answer. So that will be equal to 20 centimeter cube. Okay. So you may check by calculating the value that either we are getting the value of 20 centimeter cube or not. Right?
Sir, I'm getting 1.5 something.
1.5. Why? We
Let
have
me check.
initially we have pressure which is equals to P1, that is equals to 1 into 10 to the power 5. Next, we have V1, and V1 is equals to 40, and we have to divide it by the value of P2, that is 2 into 10 to the power 5. So the value of this 10 to the power 5 will cancel out each other because these values are same. So we just need to divide 40 by 2. So we are getting 20, right?
Okay.
So volume is equals to 20 centimeter cube. So this is the concept of Boyle's law. And if we talk about the real life application or the example of Boyle's law, so previously we are talking about that juice of the box. So if we increase the pressure, so atmospheric pressure will increase and internal pressure will decrease, right? So if we increase the pressure or if we decrease the pressure, so we can easily observe that pressure is inversely proportional to volume. And if we consider the common example of our daily life, so common example of our daily life is the breathing system of human beings or any living thing. So when we talk about the breathing system, so when we are inhaling the air molecules, so it means we are going to decrease our internal pressure and volume is increasing, right? Because air molecules are going to add up in our body and our internal pressure is going to decrease. And when we are going to exhale that air, so exhale means we are going to apply some force. So pressure will increase and all air molecules are going to be moved outward, right?
Yeah.
So breathing is the very common example of Boyle's law in our daily life. So it means every breathing is the application of Boyle's law, right? So we are every day, every second, we are working on Boyle's law.
Yes.
Okay, so further, almost it was about the 70% of the chapter because most of the concepts are basics and you already know about that. So this chapter is just the basic property or related to the basic property of solid, liquid and gas. So this topic is almost the 70% of the whole chapter. It means we have done 70% of this chapter. because when we are going to solve the question, so most of the questions are related to this P1, V1 or the properties of solid, liquid, or gas. And next topic is related to the temperature scale, that is Celsius and Kelvin, right? When we are talking about that 273 values, so that 273 value linked over here in Celsius and Kelvin scale temperature or temperature scale. In our daily life, we normally use Celsius or Fahrenheit, right? But when we are working with the thermodynamic process or the pressure and the other experiments of chemistry or any in physics, so we work with the Kelvin temperature or the Kelvin temperature scale. So first, if we compare the scales, so the difference between the scales is like that. Move this point towards right. Okay. Now, if we consider a Celsius and Kelvin scale, let's suppose at this specific point, we are having temperature 0 degrees Celsius, right? So 0 degrees Celsius is equals to 273 Kelvin, right? So this is the fixed value. You just need to remember this value, that if you want to convert Celsius into Kelvin, so we need to add 273, right? And
Okay.
if we need to find out the 0 Kelvin, so in which direction we have to move? Towards right or towards left?
Left.
Left, because on right at 0 degrees Celsius, we are having value positive 273. And we have to find out the zero value, so we have to move on left hand side. And on left hand side, we have to move towards the negative degree Celsius. That is almost over here. So at minus 273 degrees Celsius, we are getting 0 Kelvin, right? So that is the scale for this graph. It will work like this, right?
Yes.
So we have multiple variation over here. It means if we are working with Kelvin, so at 0 Kelvin, we are getting minus 273 degrees Celsius. So that is absolute temperature that we are talking about in the previous concept of the temperature of gas. So this temperature is known as absolute zero because it is related to the 0 degree Kelvin temperature, right? And if you want to convert the Celsius into Kelvin, mm, so if you want to convert from Celsius to Kelvin, so let's suppose we are having value 40 degrees Celsius. So you just need to add 273 to convert into Kelvin, right? So that will be equal to,
313.
yes, that will be equal to 313. And if you want to convert the Kelvin to Celsius, so you just need to subtract 273, right? The same process, that 313 minus 273. So you will get the exact value again in degrees Celsius, right?
Yes.
So mostly if they talk about the ideal gas or the ideal engine or any type of the thermal process, so we have to convert the Celsius degree into the Kelvin degrees, right? So this is the concept which we use to convert Celsius into Kelvin or Kelvin into Celsius. and this is the concept of absolute temperature. So any confusion till now?
No, it's clear.
Okay. So next time we will continue with some questions of this chapter, and then we will continue our next chapter, that is of thermal properties and temperature, right? Which is related to the thermal expansion, specific heat, and then we have transfer of thermal energy, right? So that was the last chapter. So we are only left with two chapters of thermal, then we will try to complete that thermal in this week also. So only we are going to left with the space, and also you need to try to complete the wave property wave section by this week. So you are going to be done with the nuclear and the wave section. And after the completion of this section, we will complete this section also. So we have done with three sections and we only left with the main section, that is of electricity, right? That will take time. Otherwise, the first section of journal physics is also easy, right?